Yeah, I can see it now.
Yes.
And the other thing I wanted to probably ask before I step into it is about the audience. So do we have a generic audience? Like who are the attendees? Are these second years, third years of all ECE? What's the
Sir, we do have students and staffs both.
okay? So it's across the department, or it's just electronics and communication?
It's basically on electronics and telecommunications, sir.
Sounds good. So I'll just
So we
start
have the computer
sharing.
science audience as well, sir. The faculty from various colleges in the computer science as well as electronics background faculty are there, sir.
Cool. Sounds good. I'm gonna start here. And it's a complete circle in a way. I graduated electronics and communication. Here I'm presenting to people that are either teaching or studying in that department, and not a lot of people can directly connect cybersecurity with electronics communication. It's just the way the fields are. But if the curriculum is still similar or same, I'm sure there's a section or rather a topic of computer networks and communication in the curriculum. And I guess that's where I had my first direct connection from academics to what I really wanted to do, and that just dominated my academic curve from there on point, be it my projects or final project submission. And I hope this sparks a bit of interest and a bit of awareness and people attending, give them the same spark that I was able to get through that subject. So I'm gonna get into the slideshow present mode. And another question I had is, I would like this to be a bit engaging of a session. So if everyone is not allowed to speak on mic, then if I could at least get people to respond out in the chat. So how can we chat here? But just
Sir, I'm audible.
sorry.
Okay, every participant is allowed to talk and
Okay,
their privilege.
amazing. Right. So let's keep it that way. Let's make it an engaging discussion. If you have a question, concern, or something just didn't make sense, feel free to just stop me and have that question. So I'd like this to be a proactive session very much. All right. So security information and event management is basically a tool um, that has over the years gained prominence in what we call security operation centers across the IT and security space. Um, since I've already been given a very fair and decent introduction, so I'm going to just skip over these introduction slides. So the first question is, what is a SIM, right? Now we already looked at what the full form was. Now, what does it mean? Why, what is a SIM? Is there someone here that already has a bit of a background that they can just talk over? I'll take that silence as a if a no. So before I step into that, I'm gonna step into here. So across organizations, there are a lot of departments, even within security, and of that is one called SOC, right? So is a security operations center is not the security team in an organization. There are so many more. So there's identity and access management, which is not usually part of the SOC. There is GRC, which is usually referred to as governance and regulatory compliance and controls. There's application security, or also known as offensive security. There is security engineering. All these security tools someone needs to manage and maintain. So there's security engineering. So And these are all unique functions in organizations, but yet, SIM is usually strongly associated with SOC, a little bit maybe with security engineering. Now, can I get a little interaction here? Anyone can here explain what a SOC is or what it may stand for? Or is it a blue or red? Um, when it comes to cybersecurity, we usually put most roles in blue and red categories, where blue is defensive and red is offensive. Can anyone take a guess as to where SOC belongs? No guesses? You can be right or wrong, 50% chances. It's either red or blue. It looks like we're gonna have a very silent crowd today. Okay. So it's very much blue in nature, and then things aren't limited to SOC when it comes to blue side. There is threat hunting as a function that is coming along. There is incident response that may or may not fall part of SOC, and just many more, right? So now the question comes, what does the SOC team do, right? Usually has a tiered analyst approach. So there's an analyst that, or rather a set of analysts that are operating, kind of monitoring alerts. The alerts are actually coming from something called a SIEM tool. This is where SIEM comes in. Then what's happening with this is that the SIEM itself isn't a source of logs, okay? And everything that is dumped into a SIEM tool is usually a log. Log from can be just from server. Logs can be from desktop. Can be from other security applications, or rather other security devices. For example, it can be from proxy. Proxy has its logs. Can be from, let's say, if you have a DLP solution in place. Everyone familiar with what is DLP? Just explain it out. The loss prevention. There would be logs from firewall. Firewalls usually have, nowadays firewalls aren't really firewalls. They're called unified threat management systems, or UTMs. So they would have their components, which used to be standalone standalone devices back in the day. So IDSs, IPSs. I'm sure if has looked into security a bit, they'll understand intrusion detection systems and prevention systems. That's what's being referred to as here. And then all these things are gonna be sending those logs into these SIM device. Some sort of rule creation, some sort of correlation would happen that would then create detections for the SOC analysts to triage incident or case, and then eventually reach out to the business or technology stakeholders to mitigate that security risk or whatever activity they've observed. So this is just a very brief overview of what it's like. Now, we'll come back to this, and yeah, but it would be, feel free to, just give a shout out if anything I'm saying is too basic, and we can take it a step, a notch above. And if it's too advanced, then we can take it a step down and try to make it more layman. So far, any questions? All right. So SIM, at the end of the day, is a way to collect logs, is a way to get all logs in a single place and then do something with it to take some sort of an action, right? So let's just keep it at that at this point, and because next time I'm going to step into why did we need a SIEM at all, right? So SIEM actually came as a solution, right? So back in the day, without SIEM, let's talk about SOCs without SIEM. There were a lot of security tools. Like, for example, all of these things mentioned here would have their own consoles, their own portals, right? Management portals. So you basically have a tool where you go and browse the proxy logs, right? You'll go and monitor the data loss prevention events and do its configuration. You will go inside the firewall to look at its logs. You would go inside the IDS to understand what alerts is it raising, what telemetry is it looking at, right? Now, the problem with this is if you've got 5 analysts and 10 tools, each of them has those 10 tools open, right? And it's not very effective, as you can imagine. And there is no central way to work on things. Like if you need to monitor 10 dashboards, you have to look at 10 dashboards. There is no way for you, unless you find a way to get it alerted or notified, um, get it over email, then you have another thing to monitor in the email, right? So the way it was this wasn't effective. The idea was to get it all um, in a single place. So the problem statement was too many security devices, which the solution was a SIEM tool. And then we'll come to the next problem. When the SIEM tool was there, what was the next problem? We'll get to that later. But now that we understand what SIEM tool is used for, which is getting different log sources in a single place, get some detection logic put in place there, some sort of a rule that, if this thing happens along with this thing, or this event is observed, create a case, and then the case gets triaged by the analyst that is working in the SOC. So now that we've talked about that there are too many SIEM tools, let's also take a look at where and how did the word SIEM come from. And magically enough, this was from Gartner, right? So Gartner, one of the Gartner analysts actually coined the term SIEM, or at least that's how it's believed. And then there's this thing called Gartner Magic Quadrant. So if none of you have ever tried to purchase security tool or any tool for that matter, I'm sure if all of you have heard the name of Gartner. If not, that's a huge research-based organization. They basically got research analysts for each and every field. They do their reports and metrics, compare different things, and kind of have become benchmark for baselining things. Right? So they have this concept of Gartner Magic Quadrant. They release this every quarter or so, and what they do is they look at the major players, the major products that are out there in the market when it comes to SIEM tools, and then they try to put them in these 4 columns, where 4 quadrants, right? As the name goes, Magic Quadrant. So there are challengers, there are niche players, there are visionaries, and then they're leaders, right? And they have their own sense of um, who is what and where and why. And a little bit of insight into this is that niche players is kind of them Gartner acknowledging you as a player. Like this is the lowest of low that you can be in. It's like if I had to say what is the weakest player in this list, I would probably go with Manage Engine, right? But I guess just being recognized by Gartner to be in the Magic Quadrant is an acknowledgement in itself, as I will soon talk about a SIEM tool that isn't even in here, right? But yet it's this is not an enumeration of everything out there. This is more like Gartner acknowledges these ones worthy of putting them in their report. And then the top one at here, Exabeam and Securonics. So these ones you can consider as the leaders. This is the best of the best. And then you see these quadrants here. Challengers are completely empty, and visionaries got some people in here. Basically, the visionaries one is got to say that they have got the vision right, but not quite the execution. So if they deliver on the promises they are making, they have huge potential to be leaders. Whereas challengers is like they've got that execution right, but they don't have so much so as a vision to be a leader, right? So this is how this magic quadrant can sometimes be used to understand if you're evaluating a product, then which one do you go for, and where they are in comparison to their peers, right? Of all the options that are available, and you'll see some big names here like McAfee, FireEye, IBM, Microsoft, right? Rapid7. All right, so that was Gartner and Magic Quadrant. Now, this is from personal experience. I'm just going to talk into what kind of SIM tools are out there, um, and what really transpires. One of the leaders here is Splunk. It's from a long time, Splunk has been one of the big SIM tool solutions. Very nifty, has its own query language, all those things. But uh, from what I last heard is I have not seen a lot of organizations using it. Like from my experience of 6.5 years, I've probably encountered 2 to 3 organizations that are actually using Splunk. And one of the primary reasons, I guess, is the cost factor. Like it's very highly priced, and just has its own ecosystem, right? Think of it as Apple of SIM tools. Next up on here is IBM Qradar. I was working with NetMagic Solutions. I was 20 to 30 customers that were IBM Qradar. So very much run-of-the-mill SIM tool. Um, I wouldn't say there's a lot about it which stands out, but it's just does the job, and this is where interesting things start to happen. So elk isn't natively a SIM tool, right? If someone's already looked at elk, they would know that this is more of a data analysis and log ingestion and data analysis solution. A lot of DevSecOps and DevOps teams that use this for their evaluation of when something's broken, where and why, and to find out quickly. Now, there's a stark difference between elk and any typical SIM, and that is of speed. Now, elk uses this concept of something called I think it's called data shards, and then reverse indexing, right? So basically, what they do is, but if what usually how you search, right? When you search something, you typically, if you ask machine, if you just put a word that search this folder in my file system, so what it usually does is looks at an index, and then you get results faster. If it doesn't have an index, it's a mammoth task to actually go through every file stored on disk, and then go through each file name and try to find that string match, right? So what elk does is it makes use of that index very aptly, and the way it does is that every word is stored as a distance from the index. Like, so for example, there are 20 words, then and of 20, 10 are in the index, then the other 10 would actually be stored in another index where they have the distance from the index of the word. So for example, there are 10 rows and something is in um, 50th column of 17th row, right? So it would have somewhere stored uh, the word that is in that cell that we want to find, and then the distance of it from the index. So it's doing that mathematical operation first of finding where that distance is less, where that numerical value is smaller, and then going into that single row to find out that particular word, right? So it just makes it much more faster. Now, just to give you a contrast, that this is not just some tech jargon where I say, this is fast and this is slow, and um, reverse indexing is the jargon that allows it to do it. Just to give you a comparison, if I had to search across 30 days worth of data in Qradar, it could take me 30 to 40 minutes to get that result out of the system, the tool, right? Same thing in ELK, less than 2 minutes, right? That's just to give you a contrast of how fast can ELK be. Right? The only downside with ELK is it's open source. It doesn't come with professional support. You gotta install it yourself, configure it yourself, do everything about it yourself, unless you can, afford to hire ELK consultants or people that, or some sort of professional services, which is then gonna take your cost close to or even more than from to Qradar. So that's a bit of a standoff that you have between. And then another one that I would mention here is DNF. I don't mention it because of its merit. I only mention it because I've used this in the past. So just allows me to give you paint a picture. Now, NIF is, so F is silent, or rather D is silent. So NIF is what they call it. And what it does is actually it's built on ELK stack. So if any of you make a career in cybersecurity, you'll find out that's it's really a common practice. So usually a basic security tool, which is open source, is usually painted over by a startup, and it's built into a tool which gives a unique functionality or just makes it more convenient for use in security operations. So NIF is actually just a paint job on ELK, is what you can say. And then I wouldn't say so. It does take that advantage of speed. So it's any day faster than any of the other ones listed here, because of ELK being at the heart of it. But then I wouldn't say it was the best implementations. Like there were a lot of customizations built into it, and then um, it just wasn't worth the effort. And also, you can see here there is no mention of so this is just to go and say to the point that this isn't listing all SIEM products ever. This is just enlisting things that Gartner acknowledges. And there are so many more products like DNF that are out there in the market, being sold and purchased by customers or rather organizations to help secure their environments. All right. So again, coming back to why SIEM, right? So we talked about the idea was to get everything on a single pane of glass, right? Make it easier for someone to be able to look at a single dashboard and say, this is going on in the environment, instead of having to continue to log in into 10 different screens and 10 different consoles, right? So it was a way to unify things. Now, there were some challenges with it, right? And there still are. So any organization using a SIEM is going to be struggling with 2 to 3 main problems. First, if either they're going to have way too many integrations, right? Too many integrations means too much EPS count. EPS stands for events per second. This is how usually they measure, you know, throughput, or rather usage of SIEM. So if you've got 100 EPS, may have some organizations or some SIEM tools actually billing you on basis of EPS, and others may just be doing it on the basis of log volume, which can be in GBs, as typical data is. And then, so yeah, the first problem is too many events, right? Too many integrations. You've got so much stuff in your SIEM that it's the infrastructure is at its limit. It can't handle all that, and there's too little utilization of creating rules out of it. Now, can someone guess why would that be? Like, you've got so much data in there, you've got so much events in there, but then there is not enough detections or not enough correlations. Can someone guess why would that scenario ever be? Come on, I guess you're allowed to speak. Take a guess. No negative marks here. Even the teachers are allowed to guess. The students feel too shy. All right, I'll take that silence as to respond. So the reason there may be too much events and not enough correlation or events that create detection, the reason for that could be that the events that are dumped into log in SIEM aren't really of quality. They aren't evaluated for their usefulness. Rather, they were just dumped because they could be dumped, right? For example, not every log has security um, relevance or implication. Not every log there um, will be used to identify if there's been a security breach or someone's abusing anything that shouldn't be done, or someone's trying to steal your network data or anything like that, right? So a lot of events are just events, and we'll take a look at that in a bit. So, and then the other problem could be with SIEM tools is that you've got too few integrations, right? Stuff that you're in there isn't just enough. And then kind of a part of the first problem. So I said there would be too few detections, but so much data. So another problem is too many detections, right? So the idea with SIEM was to bring things to a single place, yes. But then if everything in there is creating detection, then there's a problem called alert fatigue. Which is very real in today's cybersecurity space. So you've got people don't do a lot very good baselining. We'll take a look into what that is exactly. So there are two things that I've not seen being done very well. First is baselining, and the other one is inventory, right? So even till day 2021, people do not have a very good way to maintain an inventory. They do not know what devices they have in there, which subnet are they in, um, and it's not to say they have no idea. It's to say that whatever inventory they're maintaining, it's always falling short of what the true picture is, right? There's always um, some machines that make it onto the network without the due diligence or process, or there are always some machines that were believed to be decommissioned but they aren't. There are others that are part in the present in the inventory, but they were decommissioned and they were never tallied up. So maintaining a benchmark of inventory, like what is your current stock, hasn't been an easy problem for the IT to solve so far. And there are a lot of solutions and products that are doing a good job. One comes to mind called ServiceNow. It has started to do a good job of helping organizations maintain inventory, but it's still far from ideal. And the other problem is baselining. Like no one, not the network admins, not the um, desktop IT or any monitoring team understands in an organization what is their baseline. And it's the more transient an organization is, the more difficult it is to understand what your baseline is, right? So in a very perfectly controlled environment, maybe it would be easy to maintain a baseline, and that actually is true for a lot of financial technology organizations because they invest heavily in creating policies and guidelines and not allowing third-party tools, not even allowing you to download your own softwares, right? All that stuff. So what happens then is if you don't know what your baseline is, it's really difficult to understand what is not usual because you do not understand what is usual. How can you ever understand what an anomaly looks like when you don't know how your usual flow of events is like, right? So all connected challenges. Now, another problem I kind of skipped on here was um, even though you've got data from all these different sources into a single place, it's not homogeneous data, right? Some data could have different timestamps. Some data could be in a, let's say you're getting some timestamps. One could be in a UTC time zone. The other one could be local time zone, right? So all these nuances come into play when you're trying to bring in the data in a single place. Some places the IP is called IP. In other log sources it's called source, right? So now you got to compare IP with source. So it's really required to keep a tab on what kind of data is in there, under what columns, and basically the idea is to be able to normalize it. Anyway, data becomes useful to run in queries and build queries on it and get useful information. If it's normalized in a way that you wouldn't lose events if you tried to search across them. So I am carrying a use case, an example that we'll just look at in a couple minutes. So the use case would be, oh, actually, let's do that right away. So the use case would be, in an ideal world, how would a malware triage of malware being on a machine, um, how would that triage look like if it was really ideal, right? The data was homogeneous and everything we need was expected. So how does this, look like? And this isn't very far off from reality. It just takes a lot of effort to get into this place. And this one's from experience. So I was able to do it with Elk. Um, got the log sources from different places into Elk. And actually, let's do this one over here. So right, so here's your SIEM tool. Let's say this is Elk. Okay. Then I'm gonna give myself a few other tools. So I'm gonna give myself an IDS. I'm gonna give myself proxy logs to work with. I'm going to give AV antivirus. Let's say we also have the user information, and we have device information. So let's say we've got these source of logs. So we've got a database in the SIEM, which looks at all the users. So it has things like their SID. I'm not going to step into what that is for now. Let's just say it's an important attribute of a user. And then there's obviously username. That's like the primary key of this data source. And then there's context, right? Or rather memberships. What all rights does this um, user have? Like what are all different groups is this user part of? Because that defines its context, that defines its uh, rights. Like for example, it could be just a local user, it could be a domain user, it could be an administrator user, it could be a domain administrator user, which is, by the way, the most powerful account across an organization. So all right, so and then the antivirus logs, so basically, your typical events like, malware found, malware deleted, malware quarantine, malware not able to delete, all these events. So these are also going into the SIEM tool. So, the device information, right? So you've got which has the user mapping with the device, right? Like if I'm looking at this device, the host name of the device. Let's say it also has the IP information of the device. So let's say these are there itself. Okay. So these are fairly static databases, right? These would only generate new events when there's a new user created, or there's a new membership added to a group, or there's a new device added, or a new device removed. Or fairly static databases, or rather sources of information, which are in part of Elk that we are sending to Elk to make this basically trying to do what we saw here, basically make a malware triage um, easy, nifty via SIEM. So, and this is something that was done over Elk. So this isn't something straight out of theory, right? And next is your proxy logs, right? Can someone here tell me what is a HTTP response code? I'm going to continue to ask questions even if I get no response. Because come on, might have motivated someone. At least let me know you can hear me. I'm getting curious at this point. Am I audible? wow, this is a bit scary. I guess I'll just call out someone.
Okay, sir, it is from the organizing side. You are
Ah,
audible. Your
okay,
presentation
awesome.
is clear.
Okay.
Just waiting for the participant to respond.
Thank you very much. Thank you. Really appreciate that, Chetan. But yeah, I'm gonna continue to ask questions because that's the only way I know to engaging. So again, anyone here understands what a HTTP response code is? Wants to try to explain that? Right. So HTTP response code is something that is a response to a HTTP request, as the name suggests. So if you try to visit a website, it usually comes back with a HTTP response code, which is very much captured in the proxy logs. Let's take a look at HTTP response codes before I get into anything else. So anyone here has, browsed enough internet or done any troubleshooting, they would understand these. So 200 is associated with a successful activity. So basically, you search for something, and then it returned k values, like everything you search for, whatever web page you click for, whatever web server you reached out to, they were able to send you the information you were looking for, right? And that's 200. So you've got a few others in 200, but usually HTTP 200 is what you will see when a website is successfully loaded. Let's see if I can demonstrate that here. You see how there are some status codes here? Um, Along with the name resources, this actually is the same status code that means that whatever resource that was being looked for was successfully found and downloaded, so everything is as expected. So let's do here, let's open a website, right? So see how it loads a lot of resources, and I got a photo 1 for something, right? It says sign in, and then it gives me a 401. Let's take a look at what 401 is for. Right? So it says unauthorized, right? Which makes sense because I never tried to log in. So it probably checked the sign-in details. It gave me a 401 that the user is not authorized, which is fair because I just loaded the website and I didn't, I did not kind of try to log in. And maybe if this was, I was logged in, maybe this would have shown a sign in as 200 as well, right? So just a little bit on HTTP response codes. These come in really handy when trying to investigate web related malicious activity, when you're trying to ascertain if the user was able to either reach that malicious connection to that malicious website was created or not, right? All right, coming back to this. So the proxy logs will have this important detail, which is the response code, domain. Actually, it has one more important information, which is referrer URL. And then we've got the IDS, right? So let's talk about this scenario for a second here. So I'm basically looking at one scenario, which is web-based malware, right? So someone browsed a website, right? They reached out to a website that had some sort of obfuscated JavaScript that, just by visiting the website, it tried to download something on the user's machine, right? So in the old days, in the pre-ELK days, what would happen is you would get an IDS alert. Then you would check. Also, the thing with IDS is, maybe I should mention, it's a detection system. It's not a prevention system. So it means it takes traffic from a mirror port, right? So whatever you're investigating, when it's an IDS, very likely the traffic already made it to the device, right? Um, there are a few nuances into why an IDS and not an IPS and what and whatnot, but it does have an advantage, which is sandbox report. Okay, so what has happened is, let's say there is a domain www.malicious.com, right? And this domain was visited by our user, let's say Harry Potter. Okay? Harry Potter tried to visit malicious.com, and he was using a machine name called Gryffindor. Okay, so really going the magical theme here. So this is the user. They try to connect to this malicious website, which tries to download a file, magic wand .exe. Okay, so they visit this domain. It tries to download this file on this PC. That fires IDS alert, right? So what an analyst would have to do is then go into all these 5 different sources of information, get out the contextual information from on there, and then understand if this needs additional investigation or needs to be escalated or triaged. Because once they look at the IDS alert, they would understand what the threat is. Once they understand the threat, they would now say, okay, now let me see if the proxy allowed the connection and this was actually successful with the host name. So they will use the device name from here, the domain name from here, and they would try to find that in the proxy logs. And then they would look for response codes, right? So you have, actually, this also then has device or IP information, right? So they would try to find the IP and domain that was seen in the IDS alert and try to find out that response code, which would mean a connection was actually made or not. Now they would check for it and probably find, let's say, 404, right? Which means the domain, or rather 403 or any 400 related response code, which means what? Which means, for whatever reasons, the server, or actually the connection was denied. There wasn't any communication that happened. All these are different reasons why it may be, and whatever response code we find would be our answer to why, right? Um, this is very contextual. It really comes in handy. And then let's say they found it as 200 for our use case. Okay, so this interaction was 200, right? So that means a successful connection was established. Now, next thing they want to look for is the AV events. Now, AV events would also have device or rather host name. So you would have a host name information on here. Now, the host name you would look at and you will see, okay, around this timestamp, and all of these have one thing common. They will all have timestamps. It's usually very important to have basically a temporal analysis of what activity is going on, because a lot of time you're not able to connect events directly, as I was able to with IDS and proxy, because I have the same device and domain. A lot of times you have to take a bit of a leap and do some temporal analysis, right? So what has happened now is that the user was able to connect to a malicious domain, downloaded a file, magicwand.exe, which your IDS has flagged as Trojan, and it's on this machine PC Gryffindor. Now, surprisingly enough, there are no AV events on that machine, which means whatever made it to the machine was never taken care of, right? So it's still on there on that machine. And you would then want to check just the user related information. And this comes in handy because from here on, you start thinking, is this just a web-based download, like a drive-by download, or is this an adversary who is in their, who is advanced in their cyber kill chain? Interesting that I mentioned cyber kill chain. I'm just gonna bring it up here. Is cyber kill chain something people here have heard of? If you're too shy to, speak, feel free to type in chat. I can still read chat messages. You can type into privately to me, or you can type into everyone. Is cyber kill chain something you've heard of before? Because then I can just skip it and not talk about it. Yes, no, maybe. Not seeing any responses, so I'm gonna just assume that silence is for no, you have not never heard of it, and I'm just gonna talk about it a little. So the cyber kill chain basically was devised by this organization called Lockheed Martin, which is a US-based defense contractor. Um, and they, as you can imagine from the name, they're military based. So what they did was they tried to break down advanced persistent threat in the way they would apply military tactics and strategies on a typical physical adversary, right? So what they tried to do was try and break down advanced persistent threats, um, and try to break it into different parts, or rather, a kill chain, basically, for you to be able to map your whatever incident you're facing and get an understanding of where an attacker is. Now, I would include this caveat that this isn't really super relevant right now, and the reason for that is advanced persistent threat have become too advanced and too persistent, and this doesn't do a very good job of um, capturing all that sophistication. There's actually a better framework that captures this, which is called the Mitre Framework. And this has a much better, a more holistic view of what really goes on once a attacker gains and an adversary gains access to any network, right? So think of cyber kill chain as a very zoomed out version of Mitre framework. But if you're really looking for details and really going to get in the weeds, then Mitre framework is a better place, right? But if you're trying to speak with, let's say, some ID folks that don't have no concept of security, or you're trying to explain it to management and you want to be able to get that mapping out, and you want to abstain from technical details, then cyber kill chain is still a handy reference to be able to communicate past incidents, or to be able to just show where do you have detection capabilities and where do you lack them. So it starts with reconnaissance. The reconnaissance in itself is a huge topic. So it can be as physical and trivial as dumpster diving, which is just scrounging the garbage bins of the organization for data. That's why you have shredders in a lot of organizations now to save themselves from that kind of an attack. Or it can be very active. In the sense that they've gained some sort of access into the network and they're doing active enumeration, or it can still be a little bit passive and be on the internet, just looking at your online presence, your social network uh, presence, or just whatever infrastructure you have on the internet. Reconnaissance is really widespread. Weaponization is once they have that reconnaissance, once they have that information of what you're using and how, they can then try to find out vulnerabilities, right? Once they have that recon, they basically have vulnerabilities. Once they have the vulnerabilities, now they want to couple it with a exploit. An exploit is something that, call it a piece of code or a tool that can then exploit that vulnerability, right? And they would then couple that into a deliverable payload, because no matter what you've got to get it onto the machine that you really want to break into, right? So then they choose a means of delivery. Like, there are only limited ways you can get onto a machine. You can either interact it via internet. Even in internet, there's limited ways, like web browser, or email, or and then there are other things like USB, peripheral devices, etc. So once you've got that delivery done, next phase is exploitation, right? So you've got that exploit coupled with the payload onto the user's machine, and then it gets exploited, right? So you're able to make use of that vulnerability, exploit it, get some sort of access on that machine. So the next step that will follow is installation. So now you've that exploited there, you've gained some sort of better privileges, so you can go through to installation. Once installed, then this is supposed to be the backdoor, right? The installation is supposed to be a backdoor. If the backdoor is there, then this device would then reach out to your uh, server, which is here referred as command and control. So now you can actually move towards actions on objectives. So whatever you really want to do, and you can still, loop in back. Like after you get actions on keyboards, you can still go into recon, do more enumeration, and then repeat the cycle bit. So, and that's why this is a bit tricky, because this makes it feel like it ends here. But often cases, this is where a real incident starts, right? So you can think of this as a cyberkill chain for a step into the incident instead of the whole cybersecurity incident cycle. Whereas in Mitre, you see that this goes on not just steps, this goes on leaps beyond. So there are about, 14 tactics, I guess, and each tactic has its own techniques. So recon, you see here, it starts, and then until that exploitation happens, there's so much more that's going on, right? So in fact, it actually refers it to as initial access in here. But then remember how we saw command and control? That's right about here. And there are so many different things that happen before that command and control is achieved. So, and I'm not going to step into it, otherwise this just becomes the entire session. So let me just come back to the use case at hand. And so you would know from this context, basically you would understand what kind of activity is going on. Is this just an accidental download or what's going on? And then the device information helps you scope your incident. This is where things are happening. And all this would be in a single pane, right? So the analyst here can look at it all through this one instance of elk, whereas, and he can get to that decision tree much quicker. He can get to that. So for example, if this was 403, this was let's say 403, then they know that for whatever reasons the proxy connection did not succeed. If this not succeed, it makes sense that there is no AV alert, right? But now as a remediation step, they want to go check this domain. Maybe they check it on VirusTotal, right? They come here, they check for www. Malicious.com, or they do. So this will only give you a reputation based analysis. Now there's another one which is called content based. So they might go to a website like scan.io and then do www.malicious.com, and they would probably just see what content is on there, right? So this domain, what it lets you do is, without visiting an actual website, it gives you a very interesting summary, right? Gives you what's the landing page. But usually with threat adversaries, it's here. They don't usually have a landing page. They have some sort of script or remote code in the content. Basically, they're trying to get it executed straight away. So, and then you can do that analysis to understand what's really hosted on that machine. You can do the VirusTotal analysis to understand its current. Get rid of this. Yep, you can look at its current status. Now, this was analyzed 6 months ago. So let's just hit a reanalysis. And much less the same. This gives you a detail of, which domain, which IP is it hosted by, right here. This is the IP that hosting this domain, among other details. And then if the decision is then, yes, this is bad, this needs to be, we need to make sure that the other people in the organization are not doing this just because this has happened once, then the tactical way to deal with this would be to just block this domain on the network perimeter, right? You could have actually found a 403 because it's already in the block category, right? You could have already have it in your block domains category, or for whatever reason it's already categorized as malicious, and that's why it's blocked. Oh, I should actually talk about this. So a lot of organizations would have, when I said proxy, they would have some sort of a website categorization system. This is one famous one. So I could actually come here, check for this domain, and it says it's security risk for whatever reasons, and because it's in suspicious category, there's a good chance the organization may already have it blocked, and we may already see 403 or 404 in the proxy logs for that reason. So yeah, and we could continue to talk about this forever. So, but this is where I'll probably just step away from this use case. Any questions, or anyone who wants to understand anything better, or is this too much and I need to take it down a notch? I just really need to work on responses. All right, so that was a use case of how, in an ideal world, SIEM would, with the correlation of events from different log sources, would really make it much more easy to triage a web malware incident, right? So one of many examples, and that's why SIEM has a valid use case. So it's not really entirely waste. And now let's take a sneak peek into log analysis. Now this, if you thought what we looked at earlier was a bit too much in the weeds, get ready for more. So up until not too long ago, I think in 2016 is when the first time Microsoft released a proper documentation of their Windows events. And what I have here is a very useful resource uh, developed by this kind fellow named Randy Smith. And what it does is it really meticulously capture all the different event IDs across different log sources that Windows by default has enabled or not, and then needs enabling, or some options need to be tweaked. And it also captures which operating system versions and um, flavors does it have for, and it also talks about Sysmon, which we'll speak to in a bit. So one of the important ones that I can just directly create a use case in a SIEM tool is this one. It's called 1102. It's expected in event log, and it has a subcategory of log clear, and then these are all the operating system it applies to. You can see all prominent Windows operating systems are on there. And then this is how the log would look. This is the example of how the log would look. It would have the account name, which is probably your adversary account at this point. It will have a domain name. Now, if the domain name matches the device, it means it was a local account. It was not a domain account. That's a trick that we threat responders use, but it's very widely understood. And there's a logon ID. But essence of this is that someone tried to delete logs, which is one of the anti-forensics way to get in to help cover your tracks. So even if you delete the events, it will leave back an event of events deleted. So as people like to say in the forensic community, that absence of evidence is often also an evidence in itself. So very easily I could create a detection in my SIEM tool that if the event ID matches 1102, issue out, create a case which the analyst would then look at. They would understand that this user has, for whatever reasons, deleted the event logs, and then that would, start the incident response process. Now, actually, I should talk about that a bit. Let's take a look at this one. So, yeah. So basically, there are a few frameworks out there for incident response. There's one called NIST. There's one from NIST. There's one from SANS. And then usually has these parts in it. So there's basically a preparation stage. So everything you do before you are into an incident is called preparation stage. If you haven't suffered an incident yet. And then the next is detection and analysis stage, right? There has to be a starting point, like to why you've started investigating, which is the detection. Now, a lot of times this can be because you have good detections and you have that as part of your SIEM tool or whatever you've configured. And in this case, in the example that we were talking about, maybe the event 1102 would have been a good detection, right? That started the incident. And then there would be an analysis phase. We'll try to understand why and what has happened and try to scope the incident. Once you have scoped the incident, then you would start to contain it, which is to basically to say damage control, right? Things like blocking IOCs. IOCs is a term commonly understood as indicators of compromise. Then blocking IOCs, examples of IOCs are IP addresses, domains, file hashes, etc. And then once the incident is contained, now isolating devices is a good example of what happens in containing, right? Let's say you have out of 1,000 devices, you believe 50 to be impacted. You would put them in a different network zone or just isolate them from the network. Next step would be eradication, which is getting all those IPs blocked, right? And deleting all the malicious artifacts, whatever changes the attackers made inside the network and devices. A lot of times, I don't see a lot of IT having the capability of being able to eradicate properly. So they use as a one-shot solution. They use re-imaging the devices. They just re-image it. Now, there's a good and bad side to it. Good side is they make sure they get rid of everything that may have been on the machine and not investigated. The bad thing is they're fighting a war they can never win because they do not know what they're fighting against. One of the Chinese generals, they said, you've already lost a war if you're fighting against enemy unknown. So if you don't understand adversary tactics and techniques, then they're going to continue to evolve, whereas you're not going to be able to keep up with them. So often in eradication, it's recommended that you should neutralize the threat, but better safe than sorry. A lot of organizations just reimage the devices and because they want to get fast to operational stability rather than research threat actors. And then recovery is where you get everything back on in a functional state. And then post-incident activity is you try to understand at what stage of the cyber kill chain did the detection occur, and then what can you do to improve your detection so that you can catch the adversaries earlier. What kind of controls you can impose to make this better. How much time the containment took. How did the eradication happen, and all those grueling things that come out of this incident would then go feed into the preparation phase, so that the next time you face a similar incident or a new one, you're in a better state than you were you handled this one. So that's the whole idea with the incident response lifecycle at NIST. Very similar of what STANS has. Very similar concepts. Probably the only difference is it says 4 steps, and it probably has recovery as a different step, and it has 5 steps. So Yeah, coming back to the event logs, there are two more that I can speak of, which are very important and relevant. So there is an event called 4624, which is often referred to as the successful logon event. And this is how an example of a successful logon event would look like. It actually goes on to give the example from different operating systems as well. Like this is how it would look in Windows 10 in 2016. This is how it will look in 2008. This is how it will look in Windows 2012. So a lot of different details you can get from here. Usually, successful logon events become important when there's when you already know an account to be malicious or compromised, and then basically everything they did or touched becomes threat actor activity. That's where successful events take kind of center stage. Otherwise, these are happening all the time. So every time, in fact, let me see if I can show you. Let's see. Would want to go to security logs, and I would enter here for 624, and see, this is happening all the time. So I would probably ignore this one because it's a machine account. Let's see if I can filter. This doesn't have a lot of good filtering capabilities, and that's why people rely on other event viewer tools to see them. But these are very well parsed information um, in SIM tools, so it's very easy to apply. So what I was trying to do was I was trying to not apply a not condition to this and remove this MSI dollar account, because I know this to be a machine account, and I just want to observe user activity, which is my logins. But this gives you an idea of how noisy these events can be, right? You see, it's all over the place, and it's just filled with these machine account logins, right? So a lot of times you would also want to optimize your system to capture only events that are. Let's actually take a look at the failed events. That might a different picture. So see, we have two failed events. Um, this is the account name right here. So it says account for which the logon failed. This is the account that I'm using on my device. It also gives me some status code and sub-status code. I can actually check for what these mean. Let's take a look at 4625. Let's take a look at, so it says the username is correct, but the password was wrong, right? So I probably entered the wrong password, and that is why I am seeing this event logged in the Windows machine. And uh, you know, uh, probably very old. Yes, I don't type a lot, wrong password a lot, very frequently. But yeah, in a typical corporate environment where give people complex power passwords, you would be surprised how common it is to get wrong passwords. But yeah, that was that. And then let's continue moving forward. So that was a bit of Windows event log analysis, what you saw wasn't even tip of the iceberg. Um, and then there's something called Sysmon, which is part of a Microsoft utility called sysinternals. Let's also take a look at that. So this is a very useful utility from Microsoft. It has a lot of tools that can really help you dissect information on a Windows machine. The one that we're going to look at here from this is called Sysmon. Let's see where it's stored. There you go. So let's see if I have, there is the event summary. So these are the event IDs that would be generated for a Sysmon event, and you can actually configure them to either generate or not. Like you could have only 10 of these generated, or you can add additional whitelisting for a particular process. A lot of capability that comes in, and a lot of, you know, um, visibility that comes in with this. So you can observe things as pipe events. You can observe things as WMI events. WMI is something very native to the Windows operating system called Windows Management Instrumentation. If you're not familiar with IT admin stuff on a Windows box, this would probably mean nothing to you. But you would be surprised to know how much this is abused by threat adversaries. It's a very common occurrence for adversaries to do execution and persistence via using WMI. So, file deleted detected. Windows doesn't do a very good job of telling you what was deleted if I just delete it. But if you're on a device which is sensitive, you could have Sysmon configured on it, and you could enable event ID 26, and every file that is deleted would then be logged um, because of Sysmon. And if you have a SIEM tool, then you have a safe way to get it shipped out from the device, and you have it on the in your SIEM tool, and then whatever retention policy you have in your SIEM tool, you've kind of secured that evidence for a long time. There are some other interesting ones here. Process access, file create, right? And you can imagine, this will be a lot of events, right? Windows by default has so much stuff going on. Like if I was to show you how many services I have running here, um, just think, yeah. So I've probably just switched on the machine today in the morning and haven't really got to doing. I don't do a lot of development work here, and yet there are so many services already running in here, right? So just imagine being able to audit everything that goes on uh, in an environment with 1,000, 2,000 devices, right? This is just one machine. And that's why when I earlier said that baselining isn't nearly as effectively done as it could be, it should be, one of the reasons is just there's just so much going on in a Windows box. So yeah, that was a bit of a sneak peek into Windows events and Sysmon, sysinternals. Now, one last thing I'll probably add here is I'm not sure if you guys are familiar with tool called EDR, which is Endpoint Detection and Response, which is actually one of the things that I'm working. Is like a very dominant thing in my current role. Sysmon, in a way, gives you the capability to have a free EDR. Right? It's just that it comes with a lot of admin work and a lot of log management. But the level of granular details that Sysmon from sysinternal gives you, the event IDs we just looked at, this is so granular in nature. It's basically giving you EDR-like capabilities for free if you're able to kind of draw its potential and use it to effectiveness. Not going to talk about pipe events. It's just it's going to need its own discussion. And yeah, let's continue to move forward. So the future, like I said, the problem right now is there are a lot of problems with SIEM tools. So the next emerging thing is called a SOAR, which is security, orchestration, and automated response. So basically what they do is, I can actually show you an example here. Then so basically what they try to do is they build playbooks to the point that a lot of things can be just automated. For example, here's a malware outbreak playbook, and it's broken into, you know, what will happen if this detection triggers. And then the idea is to then automate a lot of those steps, so to make it so that the analysts aren't, you know, doing repetitive tasks, right? So add that flavor of orchestration, you know, get those conditional decision trees out, that if this happens, this needs to be done. Can that be automated, or is it a manual process? So basically, this is the direction. If someone says they're SOC, then in today's age, to be a standard SOC, they need a SIEM. And if they say they're we are a SOC that is 2.0 or a mature SOC, then they're, you know, either they have already transitioned into the SOAR capabilities, or they're transitioning to where they're not doing manual things for a lot of events generated from a SIEM, and they have a SOAR solution in place, right? So that's what the future holds. So there are already a lot of SOAR tools right now, and a lot of tools that just claim to be SOAR tools. So I will pause here for question answers as I approach 6 minutes to the closing time. But I do have a couple more things that I can run through if there are no questions at all. So I'm going to just pause here, have a sip of water as I wait to hear if anyone has any questions so far. All right. Doesn't sound like there are any questions. So we'll continue to. This is a bit. This isn't really about SIM, but it really is more of a cybersecurity concept that really can apply to any and whichever tool. So it isn't really part of understanding of anything about a SIM tool. More so, it's about trying to understand the adversary. So we saw something called Mitre Framework, right? So it was actually, you know, the attack in the Mitre Framework actually stands for adversary tactics and techniques and procedures, right? So basically, what TTPs are the tactics, techniques, and procedures that the threat adversary would use. Now, why is this important? Why should we be talking about it? Now, these are all the different things that are there in an attack. So you've got hash values, probably of malicious files, right? You've got IP address of the attacker, right? That they're using to attack your infrastructure. They've got domain names, so they may be using some infrastructure in the sense that they have a domain hosted. It could be for the phishing attack. It could be for the malware C2. For whatever reason, they're using a domain name, right? There are network and host artifacts that the attacker is using. And then there's tools, right? There's ransomware is an example of a threat adversary tool. They could have some sort of a remote access Trojan as part of their tool set. And at the top is the tactics, techniques, and procedures. Now, it's very trivial to change the hash of a file without ever having to change or impact its contents. Now, to give an example here, let's talk about. I have a use case which we observed in an incident. So, what really happened was also I will end up exposing you on this wonderful tool called CyberChef. So what ended up happening was there was an incident that we were dealing with at a customer, and I had two analysts running that while I was looking at the overview of it. And what kept happening was every time they will come back with a different hash for the same file name. The file name was, I think, called update.exe. And every time, sometimes they would say it's a ransomware payload, right? Next time they would say it's a network scanner. Then they would say it's AV disabling utility, right? There are utilities that just kill the antivirus, right? Sometimes they would say it's a credential dumping tool, right? So I had my analysts really running around in circles. They were really confused and worried that why do we have 5 different hashes for the same file, right? So what was actually happening in just retrospective, it took me a moment to realize that they really are being fooled by a very simple trick. Uh, the trick was that they were just renaming files every time they tried to execute something, they would just rename it with the same file name. That's all they were doing. They were all different files, and the hash was actually indicative of that information, right? A hash is always generated for the contents of the file and never about the metadata of the file. File name is not part of the file, it's considered as a metadata of the file, right? So really, you should have seen a look on their faces. They were really, out of their mind, trying to understand why, they can't understand what's going on. And just to give an example here, let's say we have a payload. Right. So let's say this is some payload. So it has this hash, right? Let me put that on here. Oops. So if when it was a payload, this was the hash. And if I added a comment in the code, right? Let's say I said, right? And you will see how that actually changed the hash, right? Even though I just added a comment which would not impact the, uh, the functionality of that binary, right? Whatever I was trying to run will still run the same. And if the attacker, if the defenders were blocking me by hash, they would really have lost a game just because I added a comment in the executable. Right? So this is a very useful utility. Goes by the name CyberChef. I guess I've already, I'm approaching I've actually crossed over 1 minute. So I'm gonna stop here, as I understand there might be a lot of other presenters, and this is a tight-packed schedule. So stop sharing here, and over to the organizer for any closing remarks, or if any people still have any questions they want to get sent my way, I'm more than happy to try and answer them. Over to you.
Yes, Mayan sir. Any participants, do you have any questions?
Finally, I saw a response in the chat.
Yes, sir. Okay. I hope there is no questions from the participant side. We really thank you, Mayan sir, for giving such a wonderful talk on security information and even management attacks. So we from Department of Telecommunication Engineering and BIT and RVS, we really thank you for all those information that you have shared. and the knowledge that you have shared for all of us. Thank you very much, sir.
It's nice. I would have really loved it if there was a little more interaction, but I guess shy crowd. So appreciate you guys